Is the TV off?
No, it's not.
That's your joke for today, is it? Couldn't think of any jokes for today.
That's me. You can report on that.
Atoms, radioactive isotopes. Okay, let's begin. Easy peasy lesson. Easy peasy lesson. Tired? Tired. You missed 1 hour of sleep because the clock changed. So when you were in at 9 o'clock, it was like 8 o'clock. Yeah. And Joan told me you were all there this morning. Congratulations. So is the secret that you only come in for 8 o'clock? Is it? Right. Okay, so radiation is not all bad. Of course, it's bad for your health, but there's some useful things about it. Now, I'll tell you which ones are important. So, I don't know if you can quite see this. Smoke alarm. There's one there. There's a tiny bit of radiation in that smoke alarm. Tiny, tiny bit. Americurium-241. Now, only a small bit, don't worry. Like, I don't know, maybe 1 gram, not much. What it does, I don't know if you can quite see it here. This is the smoke alarm. And this is positive and this is negative. And here's the, here is the radiation. Okay. Now, when the smoke alarm fills up with smoke, the radiation ionizes the smoke. So if it ionizes the smoke, what does that mean? What happens in chemistry if you say it's ionized? Yeah? Yeah, so what's released? Electrons, isn't it? Isn't that what it means to ionize, to remove electrons? So as you said, Matt, it makes the smoke become ions, which means they have a charge. Yeah. What charge would the smoke have? Positive. If it lost an electron. You guys awake? You're awake? Yeah? Awake? Okay. So, if this has a positive charge, and this is a positive plate, and this is a negative plate, then the smoke will be moved towards the negative plate. Yeah? In fact, what happens is the smoke builds up here, and it blocks the current. So this ammeter sees that there's no current anymore, because the ionized smoke blocks it. So it's like you have your 2 plates, and then this is positive, and there's a current flowing this way, an electric field. Then the smoke becomes ionized because of the radiation coming in, and so if it's ionized, it gets pulled towards in here to the negative plate. So then it blocks the current. Current goes to 0. When the current goes to 0, the alarm goes off. Okay. So one type of use is to detect the presence of smoke. These is called an ionization chamber, and they're very cheap. Basically, the smoke becomes ionized and it blocks the current. That's in one sentence. The smoke is ionized and this blocks the current. because it's drawn to the plate and acts as a barrier. This is something you need to know for the exam. I don't think they'll ask you to draw it because they usually ask you to describe it. But I think it's good if you do try to draw something to help you remember. What would they need in the exam? They need you to say it uses an ionization chamber. That's this thing here. Is this a word from chemistry? Ionization chamber? Yeah? Good. Okay, good. You can copy all of that, please. The diagram would be great as well. This is the radiation, positive, negative, current, electric power source. It's all quite simple. So this they work by detecting a break in the circuit. Fix my time. Date and time. Who has the exact time? Do you have the exact right time?
1:20.
20? Okay.
Yeah, 120.
Goodness, I'm way off. Doesn't automatically update. Doesn't have that feature working. You want to write some description, Matt? Yeah.
So what is the green thing?
The green thing? You mean this thing?
Yeah.
Oh, that's just your radioactive isotope. That's your radioactive material.
What is the physics that report do?
Well, I wanted to start it today, so we'll start it tomorrow, and we make it maybe 4 weeks. We'll work on it bit by bit. So tomorrow what we'll do is put this into Excel, make the graphs, and do a little bit of analysis. For example, like calculating the slope, things like this. Okay, you got that? Okay. You okay, Joe? You tired? Ah, this must be Siba.
They were like, April
What did you say to her?
No, he said he was not coming.
Ah, they played a joke on Kim.
But the application was DCU is delay, right?
Yeah, did you get in?
You were making a DCU application and it's delayed? Is this what happened?
Yeah, they rescheduled.
you not get this email?
They just rescheduled it now.
Like 5 minutes before it started?
5
Nice.
minutes after it started.
Nice. Nice. That is your results you can use. You know, your results. You look confused. Confused? No. Continue. Antak, you have this?
Just a bit.
Yeah? Continue?
Yeah.
Okay. Right. Fluorine 18. Oh. Did you write down the name of the material? And its half-life is 400 years. Yeah? Yeah? Continue? So the next one we'll have a look at is this radioactive isotope called fluorine 18. Now, this one is used for finding a leak in water supply, and its half-life is only 2 hours. So what they do, there's some leak. You don't know where the leak is. So they put this into the water. And what will happen is, imagine the leak is here, well then it'll come, the water comes out of the pipe here, in the ground. If you're walking above the ground with your Geiger counter, you know, remember the Geiger counter, it makes the click for the radiation. So as you're walking, if it starts to click, then it means the ground is radioactive, which means that must be where the leak is, because the radioactive water is coming out. Now, because the half-life is only 2 hours, it would mean after 24 hours it should be safe to drink again. Yeah. So it's used to find leaks in water, fluorine 18. A radioactive tracer is a chemical compound in which one or more atoms have been replaced by a radioactive isotope. So a tracer is, well, you know this word maybe, tracer. Do you know this word? I know there's a, isn't that person called Tracer? You know, from the video game.
Sounds familiar.
You know what I'm talking about. What's it called? What was the very popular game before Fortnite? That's the one. That's the one. Overwatch. Isn't there some?
Is Overwatch famous?
Isn't it?
What? It is, isn't it?
Isn't the one of the characters called Tracer?
It is, but
Yeah.
it is. I saw quickly.
It is.
Anyways, you know. Do you know the character called Tracer? Yeah. So, Tracer is a way. It's like tracking to find something. So this fluorine 18 is called a tracer. It's something that you add to the water to help you find where the leak is. I know there's a lot there to write down, I'm sorry, but if you want, you can draw the picture to help. You know, like imagine you have a big city and there's water leaking somewhere underground. You can't dig up the whole city to find where the leak is. Now, this is one way you can do it. You make the water radioactive and then you can see where it's leaking out from. Has any of you ever seen this before?
Movies.
In movies? Which movie? I've never seen it in a movie.
Movies is that.
Are you sure not just a metal detector?
Maybe some movie too.
Huh?
Just a minute.
Maybe some.
Well,
What movie?
Just a minute.
Mr. Bean. Matt, you're finished. You wrote this down? You wrote something down. A summary. Are you stealing Siba's coffee? I thought you don't drink coffee. Today, what's so special about today? Aha. Makes sense. Alright, fluorine 18, half-life 2 hours. You got that? Is it having any effect? Is it Oh, go on then. You're not going to be able to concentrate on this without it. You got that? Yeah? Okay. The next one, technetium 99M, and don't ask me, I don't know what the M stands for. Now, this one here, this is what they use at hospitals. So they, how do they do this? I think they inject it into you, an injection, yeah, and it enters your body. And it's radioactive, which you might say, that's quite dangerous. It has a half-life of 2 hours. So it'll take about 24 hours before it fully leaves your body. Now, for those of you who've studied biology before, the colour means how radioactive it is. So in other words, the more red, the more radioactive it is. Why do you think there's some red spots here and here? Or here and here? Why is there a concentration here? Any ideas? No. Good guess. Not this. Anyone know?
It's where they're not feeling well, or
No. Nobody knows what's special about these spots?
High pressure.
No. Nobody?
heat,
No. Have none of you studied biology before?
not this
Not this part. So you have
leaves.
yeah, 2 here, lymph nodes, aren't they? 2 here and 2 here under your arms and here, isn't it? And their job, do you know what their job is? Does anyone know? Yeah? Yeah, so what do they do? Like, what's their job? What's their purpose? No? So, basically, they act like, try to clean, you know?
Yeah, it has white blood cells.
Yeah, exactly, yeah. It's like a cleaning centre, nearly. Now, you know this because sometimes when you get sick, sometimes you get swollen here, it swells. Sometimes you get very hot here. It's because they're working so hard, okay? So what the body is trying to do is trying to get the radiation out. So that's why it's collected here and here, okay? I kind of think, I don't know, this might be his kidneys, I'm not sure. Kidneys, I don't know. And what about this?
Liver.
Liver, yeah. Which is not as dark. But the liver also has a purpose of filtering, of cleaning. You know, so like when you drink alcohol, for example, Kim, your liver has to work hard to clean this toxin out of your body. So it works a little bit harder. Now, why might you inject somebody with this? Well, you know x-rays. Has anyone had an x-ray before? Yeah, where did you get x-rayed? In the mouth, yeah, me too. I think we've all had dentist x-ray. Has anyone had an x-ray of their body, like they broke a bone? Yeah? What bone did you break?
Well, not broken bone, but
Yeah?
FRI.
Where?
that's broken.
Oh yeah, no, I'm just talking about an x-ray, just a simple x-ray. Yeah, you had a full body x-ray?
Yeah.
Yeah?
You just not full body, just the
Lower half then, yeah. So, x-rays only work to show you bones, right? X-rays can't show you, like, if you damaged your kidney, or if you damaged your heart, or your liver. So what they do is they put this into the person, and they could see, for example, if maybe there's a hole, or something's damaged. It gives them a picture of their organs. Do you understand? Yeah. So the most common one is technetium 99M. 30 million people per year use this, and 4 out of 5 imaging procedures use this. So in other words, if you're getting some kind of scan image, 80% chance that it's going to be like this, using this material. I don't know, has anybody had anything like this before? No? Probably not. I think it's used for, one example I think it's with cancer, so they can get a picture of where things are growing, you know. Another example, you know, sometimes people have their heart damage, like there's a tear or there's a hole, they can get a picture of this, you know. So it's also dangerous because it's radioactive, so you have to make a balance, you know, which is worse, giving the person this or not knowing what's wrong with them, you know. So it's a balance between the two. Okay, you could draw a picture if you like, but maybe you could at least write this down. You said you had an MRI before? For reals? Inside the site? How long were you inside for? Yeah. Can't move. Do they play any music or anything to... You're just sitting there, nothing to do. Not even it's music. No, nothing. Goodness. You got this? Yeah, okay. Next one. Cobalt-60. Basically, it's used like an X-ray. I think it's used, I think they use it for security, like in the picture here. Maybe at airports or ports. It's a little bit like an X-ray, but I don't think it's as powerful as an X-ray. So it's able to detect more of the structure. Basically, it's used like an X-ray image. Gamma radiation, most commonly iridium or cobalt, are used to inspect materials. So really, if you're working in any kind of, is anybody here doing industrial engineering or anything like that next year? What did you say? What were you doing on deck next year?
Product design.
Product design, SIBA? Ah, no, you're doing biomedical, so that means the previous one here is something you'd see again. Kim? Which one? Mechanical. What was yours? Oh, definitely not then. And what did you say you're doing next year, Chow?
Psychology.
Psychology, definitely not then. Okay, so they use this if they want to inspect like structures to see if they're safe, nothing's broken. They also use it for security if they want to check the inside of a container. You know what I mean? It's like it's kind of like an X-ray image, except it uses gamma radiation instead of X-rays. Oh my goodness, I'm having trouble too. Continue?
Just a bit.
Are you drawing in your man?
Yeah, no.
Yeah?
1 second. Yeah, finish.
Yeah? Yeah? Okay. Next. So this one is quite interesting. This is a way for treating cancer. And this is interesting because it uses boron-10. Now boron-10 is stable. It's not radioactive. And neutrons. And the half-life is basically pretty much 0 seconds. So I just want to explain how this works with a little picture. So I think this is quite interesting. So let's imagine there's the person's skin. and then we'll say inside of them there's the cancer. That is there. Now, how to treat this? So there's many ways to treat it, but this one is interesting. What they do is they inject into the cancer some boron 10. So this boron 10 is inside of the cancer here. And then what they do, so take that away, there's your boron 10. Then they fire some neutrons straight down. And they don't really do any damage until they hit boron 10. So what will happen is you'll get boron 10 plus a neutron. This, I think, becomes boron 11. Now, boron 11 is very radioactive and has a very short half-life. So basically what happens is it's like it explodes. It just releases all the energy and then becomes stable quickly. So when the neutron hits this, basically, like I said, all the radiation is released. Alpha, beta, and gamma in like 0 seconds, instantly. So it destroys the cancer from the inside, like blows it up from the inside. I think this is very interesting. This is like new. Oh, so this is like new research. This is like new cancer treatment. So why is this different? Wait. Just wait. Does anybody know chemotherapy? Yeah. So chemotherapy makes the patient quite sick because their whole body gets the treatment. Whereas this treatment is what's called a local treatment, meaning only the cancer gets the radiation. Okay? So there are many other ways of doing this. Boron 10 was an example I found on the internet. Where did you say, Siba, you want to do the biophysics? Is it biophysics? What's it called?
Biomedical.
Biomedical, yeah. Where did you want to study that? Galway, okay. I think they have good facilities. I don't know if, I don't know, have you been to Galway's university? Have you seen the department you would be in? Big, small?
Yeah.
It's big, yeah. Modern? Yeah, that's good. That's good. Are you thinking of, like, is your plan to be in a job like this person here, radiologist, or?
Want to specialize in prosthetics.
Ah, I see, very good, okay, yeah. that's lots of interesting stuff with prosthetics, because they have some prosthetics now that could be robotic and different materials like this. Because I think, I'm not sure, maybe you might know, but I think, are they able to connect them up to your nerves or something? To get some kind of movement. Yeah. Yeah, that's interesting stuff. Okay, continue. Yeah. Now this one, back to cobalt 60 again. Food irritation. Does anybody know what that means? Food irritation.
Process of food,
Yeah, how so though?
like cooking.
I know. Not as boring as that. More exciting. I suppose cooking is a type, perhaps, of irritation, but something else. Yeah, now we're getting closer. It does have something to do with preserving. Yeah. So of course you know. All right. When you buy an apple, you leave the apple on the table. What happens to the apple? It rots. Okay. Why does it rot? Because there are things that live on the outside of the apple that eat the apple, like bacteria, right? Okay, so like you have your apple, there's bacteria on it. I'm sorry, it's on all your food that you eat, and it eats the food. And if you leave it out, it'll just eat the food slowly, and that it rots and it smells and so on. Now, if you want your apple to last longer, what would you need to do? You would need to remove the insects and the dirt and the bacteria that's on the outside of the apple. Okay? How can you do that? Well, by what? Yes, that's fine. Yeah, that would be an old way of doing it. Yeah. So in the past, maybe hundreds of years ago, people did things like they would boil it, they would pickle it, do things like this. Modern days, what would we do to kind of clean the outside of the food? What would the farmer do? Spray it. They put a spray on it. What's the problem with putting a spray on it? Well, then you too read the spray. But another thing you could do is you could put some radiation on it. And the radiation would kill the bacteria on it. And it has a second benefit as well. So, imagine you had little insects living on your apple. Okay? And the insects eat the apple, and then they make more insects, and there's more insects, and so on, and so on, and so on. If you fire some radiation at the insects, it means the boy insects will not be able to make baby insects with the girl insects, because the radiation makes them no good for this anymore, if you know what I mean. Yes? You understand what I'm saying?
So
Yeah.
radiation kills the insects.
No, it can kill the insects and also make them not able to reproduce from the radiation. So the insects, some of them die, and then the rest, the ones who don't die, can't have more insects, so then it's all clean then. So food irritation, you can use cobalt. Now you might say, so that means my apple is radioactive? And it's like, yeah, it does. And you might say, is that bad for me? And I would say, not so bad. Because, trust me, it's much worse if you eat an apple that has some bad bacteria in it and it gets inside of you. Okay? Like, there's some really, I don't know, food poisoning. Yeah. You can get really bad food poisoning. Like, there's some really bad bacteria out there. So it's probably better to have the radiation than the bacteria inside of you. Because I think some food poisoning, like, it could make you blind or something. It's like, I don't know. Yeah. Yeah, there's some, like, really bad food poisoning out there. Like, what's the one, salmonella? Is this the one on chicken or something? Salmonella? Yeah. Do you know this one? No. Which one?
Eggs.
On eggs, yeah. Yeah. So, for example, the eggs, I think what they do in America is they put a kind of a bleach on the eggs to kill anything on the eggs. That's why American eggs are white. It's true. It's because they have a bleach on them. Yeah. Did you know this?
Or eggs are red.
Never bought.
Wow, that's interesting. So they might have been bleached. Tell me this, when you go to the shop to buy eggs, are they in the fridge or not in the fridge?
No, in the fridge.
Like an oven.
In the fridge. Then they've been bleached. Because when, I don't know if you noticed this, but when you go to Ireland and you buy eggs, they're not in the fridge because they've not been bleached. You only need to put the eggs in the fridge if they've been bleached.
Yeah, because I notice here, like, my housemates don't put their eggs in the
Yeah.
fridge, but I put mine.
Yeah, well that's fine if you do, but here you don't need to because you only need to put white eggs in the fridge if they've been bleached. And the reason for that is because when you bleach an egg, it gets thinner, which means it the inside is less protected, so you would need to keep it cooler to keep it fresh. Whereas when the egg is brown, it's more protected from the outside, so it doesn't go bad. Yeah. So that means you've been eating bleached eggs back home. Just think about that now. Okay. So food irritation is a way of cleaning the food and making it last longer. It's a process of exposing food to radiation. This is used, as you said, Andek, to preserve food, to make it last longer. Reduce the risk of food-borne illness. This means reduce food poisoning. Prevent the spread of pests. What are pests? Insects. Yeah. And delay sprouting or ripening. What do they mean by that? So do you know when you get some fruit and it goes ripe, it turns black? It delays that process. Irradiated food does not become radioactive. Now, I know it says it doesn't become radioactive, but I find that kind of a little bit difficult to believe because since you're spraying radiation on it, but got that? Got that? Yeah?
1 second.
Oh.
Finish.
Continue? Yeah. Ready, guys? Yeah. So the last one here is something called carbon-14. Now, what is the normal mass number for carbon? 12. So carbon-14 has 2 extra neutrons, and this makes it radioactive. And carbon-14 is in our atmosphere. Okay? And what happens is the carbon-14, I think it decays into carbon and nitrogen? I think so. I'm not sure. Anyways, that's not important. So the carbon-14 is radioactive. It's inside our atmosphere. Now this one's interesting. You might have heard of this one before. I think we were talking about it in class before. So because carbon-14 is in the air, that means it gets inside the trees, because the trees, you know, they take the air inside of them and they release oxygen. They take carbon dioxide. So then the carbon gets inside the trees and the grass. And then the animals eat the grass. So the carbon that was in the food is now in the animals. And then we eat the animals. And so carbon-14 is inside of us. So all of us have a little bit of radioactive carbon-14 inside of us. Okay? This table has it. Why? Because it's made from a dead tree. You know? If you ate something for lunch, that has carbon-14 in it. Everything that's alive has carbon-14 in it. Then when it dies, the carbon-14 starts to decay, because it's not getting more carbon-14 inside of it. So if you measure how much carbon-14 is in something, then you can know how long ago it died. So if there's only half the carbon-14 inside, then it's 5,000 years old. You get the idea? Yeah. Has anybody ever heard of this before? Called carbon dating. You've heard of this before? You've heard of this before? Yeah. It's how they can date old books and artifacts and things like this. So it's a dating method that uses carbon-14 to determine the age of carbo something something. Carbonaceous. What?
Carbonaceous.
Carbonaceous?
Carbonaceous.
Carbon-based material. So it's the age of carbon-based material. Sorry, this word here is the adjective for carbon. Carbonaceous, okay. No fighting, guys. Be nice, please. Now for the exam, the most important two is the first one and the last one. They're most important for the exam. There's a good chance they'll ask you something about one of those two. The first one and the last one. Can you put it like a little star, maybe write exam beside the first and the last one? That'd be useful. Okay. First and last.
The tracer and
No, first one was the smoke alarm, wasn't it?
smoke detector and the carbon dating.
The carbon-14 here. Continue. Yeah. So we'll go on to the next lesson. So, what's the next one called?